Welcome, everyone. Thank you for taking the time to join us for this webinar session today. My name is Katharina, and I will moderate today's webinar with the subject Best Practice for Hard Chrome Plating. First and foremost, I would like to introduce our speakers for today. Shakil Akhtar, Global Product Manager and Business Development Manager for wear-resistant coatings, has worked for Atotech for almost 30 years. As a specialist in electroless nickel plating, he has extensive knowledge of surface finishing, including functional chrome. At Atotech, Shakil has held various positions such as R&D development chemist, product specialist, global application manager, technology manager, and product manager for wear-resistant coatings. He has gained extensive international experience in serving customers around the world and was based in Singapore for 6 years. In his current position, Shakil oversees Atotech's global product range and business development opportunities for wear-resistant coatings. And our second speaker I would like to introduce to you is Matthias Schmidt, who holds a degree in electroplating and has more than 17 years of experience in the field of electroplating technology. He has broad knowledge of the surface finishing industry and has specialized in the fields of functional chrome and electroless nickel plating. Matthias joined Atotech in 2009 and has worked in various positions within the organization. He served as a global application manager for functional chrome for many years, and in his role he has provided technical support to the sales team and carried out on-site troubleshooting and customer trainings. In his current position, Matthias is responsible for the functional chrome and electroless nickel business in Germany and Switzerland. Welcome, Shakil and Matthias. I would like to say a couple of words about the webinar before we start. So the webinar will be divided in two major parts, 45 minutes presentation and 10 minutes Q&A session. I encourage you to raise questions during the presentation, and therefore you can use the Q&A function, which you can find on the top right corner of your screen. Keeping confidentiality, we will not publish the questions, so you can see the question which you have posted yourself into the section, but you can't see any other questions. We will try to cover as many questions as possible during the planned Q&A session. At the end of the presentation, if the time allows, we will answer all questions right away. Also, Mr. Akhtar and Mr. Schmidt will be available after the webinar to reach out to you via email. Last but not least, there will be a recording available after this webinar session, and we will let you know when it is released and send the link via email to you. Now, let me hand over to Shakil and Matthias, and please enjoy the session.
Thank you, Katharina, for your kind introduction. First of all, please let me welcome everyone taking part in this webinar today and appreciate your interest in this topic. The objective of today's webinar is to give you an overview of what hard chrome plating is all about and share our experiences with you in order to help you improve your production and the best available process and technology. So let me start with the agenda first. In today's presentation, the content will mainly focus on explaining the main points about what is hard chrome plating, why we use it to plate metals. We will highlight the important properties that need to be utilized to achieve the best quality. We aim to provide you with information about the typical applications where hard chrome is used. We will highlight to you the important factors which need to be considered, such as the pre-plate steps, the chrome plating process, the post-plating finishing stages. We will give you an overview of the common types of equipment used and the improvements made in the anode technology to optimize production further. So let's start with the first section of the presentation and find out what chrome is all about. So chrome plating comes in two forms, and this is a decorative plating and hard chrome plating. Decorative plating, as the term suggests, is all about achieving the best possible cosmetic finish on the component. Here, the chrome layer is applied on top of copper nickel coatings and serves no other function than to produce a bright finish. It has no significant impact on improving the wear or the corrosion resistance of the substrate, and is typically plated to 1 micron thickness for bulk of the decorative applications. Nowadays, the chrome can plate in other color finishes other than the traditional bright blue. Hard chrome, on the other hand, is plated to improve the lifetime of the component in service. It is usually plated to thicknesses ranging from 5 microns up to 300 microns, of course, depending on the application requirements, and in some rare cases, even higher than 300 microns are plated. The process is used at much higher temperature and cathode current densities compared to decorative plating. So these are the main differences between the two type of chrome plating. The most important properties to consider, and the main reason why we try and plate hard chrome deposits is that number one is usually the hardness, which imparts high resistance to wear, which is of course very important in terms of prolonging the life of the components. And secondly, hard chrome deposits provide good coefficient of friction. This means the sliding properties of the deposit, which make it possible for the coating to be used in extreme environments with reciprocating dynamic movement. Of the metals which are electroplated, chromium has the highest hardness. Hence, it is ideal for extending the life of the components in very severe industrial environments. The hard chromium plating process in general are not very efficient processes, as can be seen from the table here. So you can achieve between 10 to 30% efficiency from the process. Many important developments have been made over the years to improve this. Originally, we started off with the Sargent formulation, which was only capable of giving 12 to 15%. But due to some innovation from Atotech and its predecessors, we were able to push this efficiency up to above 20 to 23%. Atotech offers a wide variety of electrolytes to meet almost every type of plating required within the industry for hard chrome plating. Appearance can be anything matte to bright depending on factors such as thickness, catalyst system, and current and temperature used. Many of you are already informed of important regulation changes which are going to be enforced by the EU in the very near future. The latest update is that there is a meeting taking place in September, in which we may expect a final decision could be made by the EU. For those of you not familiar with this new regulation being enforced through, the objective of this is to ban the use of hexavalent chromium within the EU countries by 2024. Atotech has already taken the necessary steps to counter this, and we have recently introduced into the market our trivalent chrome process, blue chrome. This is the first commercially available process in the industry, which is based on trivalent chromium. Atotech has a rich history, and many of you already are familiar with this, and this goes back to since 1927, as being the leading supplier of robust and reliable hard chrome plating processes. As you can see from the timeline, Atotech completely revolutionized the industry back in 1985 with our development of the very first high-efficiency etch-free process. And this was our Heave 25. And then introduced our Dynachrome concept for rod plating in 1995. We continue to innovate, and with our Heave HMC process, we launched this in 2018. And this is our latest offering. And for sure, in terms of further revolutionary changes, we have introduced our blue chrome process, which is our trivalent hard chrome process. So again, we anticipate that we will completely revolutionize the industry with this process. An important point to mention is that Atotech is very committed to offering service to our customers. And our service commitment to our customers is second to none, and this is appreciated by most customers. We are currently operating 7 technical centers around the world, which are dedicated, which has dedicated equipment for wear-resistant coatings, and we provide sample plating facilities in most of these to support our customer requirements. Our next section, the presentation, aims to explain important deposit characteristics which provide the reason for using hard chromium plating. So what are the benefits of hard chromium plating? Why is hard chromium plating used to plate components? And the main reasons are that the main benefits which are important for hard chrome deposits are, number one, the service lifetime of the components is extended. Number two, hard chrome deposits impart superior tribological properties to the component, such as low coefficient of friction, high hardness, which gives rise to high wear resistance, and high corrosion resistance. One of the characteristics of hard chrome deposits is the formation of the cracks within the coating, and these cracks provide important benefits. So let's look at how these form within the coating. A hard chromium coating has cracks, and these cracks, if we view them from the surface under magnification, these appear as a crazy paving pattern. The cracks help to spread the corrosion potential and provide lubrication by trapping oil. It is important to form a dense network of fine cracks rather than having a few macro cracks. Macro cracks should be avoided at all costs. Macro cracks will have a tendency to reduce corrosion protection, as it provides a pathway to the base material for corrosive media. So what causes these cracks to form in the coating? So let's take a look. On this slide, we can see the change in the stress as the thickness of the coating is increased. So what tends to happen during plating is that we plate a chromium hydride layer. And this is crystalline and has a hexagonal face-centered lattice. And you can see the inclusion of the hydrogen atoms if we look at the structure on the top right-hand corner of the slide. And this structure is very unstable. And what tends to happen is that as we lose the hydrogen from the coating, and this loss of hydrogen forces a change in the structure of the deposit. So we form a body-centered cubic lattice structure. And this change in the structure has an impact in terms of a shrinkage in the crystal size structure. So we see a 15% shrinkage in the crystal size. And this leads to tensile stresses forming within the coating. And the only way the deposit can overcome these stresses is that it starts to crack. So if we go and look at the next slide, which shows us what is happening in terms of the internal stress as the thickness is building up. So as the cracks form, we create a pattern of cracks which are staggered, because what tends to happen is within the first cracks forming, we get more deposition, those cracks are covered, and then the stress builds up again and the deposit cracks again. And this process is repeated as the plating progresses. So one important criteria for the process is to ensure that we don't crack the deposits in the same place as the crack underneath. So our objective is to form cracks which are staggered to one another. And it is imperative that the cracks are not aligned, otherwise it leads to macro cracks forming. Base material defects, of course, have a big impact. And the effect of aiding alignment, these should be avoided at all costs to avoid corrosion failures. With the traditional chrome plating processes, we observe a drop in the crack count numbers as cathode current density increases. So to counter this effect, Atotech has developed its HEAF HMC process. And HMC stands for high micro cracks. With the HMC process, we can achieve a plus 30% higher number of cracks compared to HEAF 25 at a given nominal 30 amps per square decimeter. But when the cathode current density is increased from 30 to say 120, this difference becomes bigger. And the reason for this is that with HEAF 25, as you increase the current density, the crack count reduces in number. But with our HMC process, we maintain the same number of cracks despite the increasing current density. So let's now move on to our next section. In this section, we will highlight applications requiring hard chrome. So I now hand over to my colleague, Matthias Schmidt.
Thank you, Shakil, and warm welcome also from my side. I will guide you through the second part of our presentation. Hard chrome is used in the field of electroplating for a various number of different applications in order to increase the lifetime of the components significantly during their operation. The main applications are the automotive industry, the hydraulics industry, and also oil and gas as a very important sector. But it's also used for aerospace and military applications, for railroad, and also for the printing industry, as well as for cold rollers in steel mills to extend the lifetime of the rollers, which are finally rolling down the steel. If we're looking more in detail to the automotive industry, the typical parts plated are engine valves, piston rings. We have the brake pistons in the brake systems, cylinder liners, and a very, very big field is suspension struts or shock absorbers at the wheel area of the the parts, you can see the typically applied thicknesses next to the parts shown in the pictures. If it's about automotive, the processes used in automotive industry or also in general for functional chrome plating, there is no standard process for each and every application. There's always options depending on customer requirements and plating technology used, which kind of process is used. You see here a various palette of different processes for the certain parts which are plated. As an example, for shock absorber rods, in the middle of the table, you can use a high-speed system like Dynachrome with specialized chemistry for that application. But it's also possible to plate them in a traditional way in conventional lines, which then would you would choose a heave type of process to plate these kind of parts. Moving to the next slide, for the oil and gas applications, the requirements here are usually a good wear resistance and definitely a very, very good corrosion protection. The kind of parts plated for this industry is basically rotors or pump barrels. For the rotors, which you can see on the top right picture, there's two different kinds. It's on one side the power rotors, which are used during the drilling operation to move some drilling mud to improve or to support the drilling. And the other type of parts are pump rotors, which are actually used for the extraction of the oil or the gas out of the ground. These parts usually get very, very high thickness of 250 to 300 micron because they have to withstand a very strong, partly very strong chloride or sulfur dioxide atmospheres, which are attacking the chrome very, very strongly. Another part in this field are pump barrels. This is actually the barrels which transport the oil or gas out of the ground. They are inside plated typically in very, very deep tanks. And since the parts are very long, up to 46 feet, usually there is a shorter anode used, which is traveling inside the barrel during plating up and down in order to provide the current which is needed for the plating. The field of hydraulics, it's also a very, very big and important field. Here, usually hydraulic components for cranes, for earth moving equipment or other machines. These components are plated. Typically a very, very good or a superior corrosion and wear protection are required. The chemistry must be set up and controlled in a very, very good way to achieve a high productivity and a very good quality. And also here in the red square, you can see a recommendation of different processes. This is basically the chemistry is also had to be improved because the demands for corrosion resistance in this field of industry were increasing or are continuously increasing. So microcrack number and corrosion protection are very, very important. So depending on the requirement of how much corrosion resistance is required, different processes like Heave 25, Heave KR, Heave HMC can be selected. Yeah, let's move on to a short section of pre and post finishing. Pre-treatment for hard chrome applications are usually or can usually be very, very short. The red squares on the right side indicate the process steps related to a plating division, and the green steps are actually mechanical pre-treatment and the mechanical or by temperature post-treatment. Typically the substrate must be in a very, very good quality. So the grinding or the mechanical pretreatment operations have to produce a defect and sliver-free surface. In the plating section, of course, the right process for the kind of equipment or for the requirements of the final layer has to be chosen. And the post finishing is very, very important in order to remove possibly hydrogen which moved into the substrate for very, very high tensile strength materials. And it's very, very important to release the high tensile stress, to release the very high tensile stress of the chrome plating in order to achieve a good performance and a very, very good corrosion resistance. It's important to be to have very, very good results in each of the sections, because one weak spot in one of these areas can strongly impact the part performance and the final corrosion resistance of the plated part. Here you see some defects which can, on the top right side, you can see some defects like slivers which can be produced in the pre-grinding operations. An etching process as the last step before the chrome plating can reduce or can remove some of these slivers or some of these defects, but it's usually not able to cover everything. So in the best case or in the optimum case, these kind of slivers or defects are removed in the pre-grinding operation. By adjusting the etching parameters, they can be etched away. You see on the bottom side with a mild etching on the left side, the sliver on the surface would stand up due to the current which is applied. By increasing the etching, the middle picture, the sliver is standing up further, and with the right and strong enough etching parameters, the sliver will be etched away. Yeah, as already mentioned, etching is usually the last step before the plating. Today, there's different options are possible. Typically, the etching is carried out in a chrome 6 containing separate etch tank, which is usually recommended, but some customers also etch directly inside the chrome tank. And with the introduction of the blue chrome, etching in chrome 6 solutions are not possible anymore. So we are also, Atotech is also providing chrome 6 and CMR-free etching or pretreatment solutions in order to prepare the substrate also for these new types of processes. We have several cleaners which should usually be phosphate-free for different alloys, for copper and steel. And to complete our portfolio, there is also several solutions for chrome removal, like the Unistrip no-cure, or like chrome reducers or neutralizers to remove the residues of chrome 6 from the final plated parts. Another important area in the post-treatment is the heat treatment or annealing plus the post-grinding. As already mentioned, the chrome plated has very, very high tensile stress. And with the annealing, the stress release of the chrome layer is actually beginning. In case of very, very high tensile strength materials, like for aerospace applications with tensile strengths of more than 1,000 Newton per square millimeter, it's recommended to do a heat treatment in order to release or remove the hydrogen, which might have been migrated into the substrate and can cause tension and stress if it's not removed. During the annealing process, the stress release or the crack number increase is not very high. So in any case, to remove the high tensile strength, the post-finishing or post-grinding is required. Here, the main part of the tensile stress is removed. transformed into compressive stress, and with this stress release, the microcrack number of the chrome layer is increasing significantly. In an optimum case, it doubles or even triples in some cases. Yeah, now let's look a bit deeper inside the plating bath and the analytical control of chrome plating baths. In order to achieve the best quality for the customer requirements, Atotech is usually supporting our customers with the right choice of the process, which with like a high microcrack count, depending on the requirements. We typically assist our customers in process control, which means we give local support and training how to run the process in an optimal way. And also, of course, for the bath maintenance, in order to keep the bath in a certain range, operating range, Atotech offers analytical methods and local customer support in order to keep the bath within the right parameters. Further to that, or in addition to that, we also take care for a safe operation at production sites. So we support customers with the switch from typically used solid chromic acid to liquid chromic acid to avoid the dust and the chrome 6 dust inside the plating shops. We have chrome 6 free additive products to be added. We also support with the use of inert anodes in order to avoid the sludge generation of the lead tin anodes. We have fume suppressants to keep the emissions on a controlled level. And of course, we also support our customers with high-end plating equipment for shock absorbers, high-speed plating, or other high-speed platings for other applications like engine valves. The next slide is showing you the typical setup of a chrome plating bath. On the left side, you see the typical components in chrome plating baths. We have a chromic acid as the main deliverer of the chrome with an amount of about 250 grams per liter. A sulfate as the first catalyst, which is making the chrome plating possible in a first stage between 2 and 5 grams per liter, depending on application. There can be several catalysts inside the bath. They should be operated, of course, in a level of about 100%. The contaminants in the chrome baths are usually trivalent chrome, which is formed as a part during the plating, and iron, which is usually coming from the steel parts from the etching process. We recommend to have no higher total metal contamination than 18 grams per liter. From that level on, the performance of the layer and the performance of the plating is going down significantly. We usually operate at 50 to 75 degrees centigrade. These high-end 75 or 185 amps per square decimeters, this is then usually the high-speed plating in Dynachrome platers or for engine valves. Typically, the operation range of the heave process or of most of the processes is about 50 amps per square decimeter at 50 to 60 degrees centigrade, which will give you a plating rate of about 1 micron per minute, 60 microns per hour with the heave process. If it's coming to analytical control of the chrome plating baths, some of the measures are taken on customer side. The others are usually done by Atotech. Typically, customers analyze chromic acid and sulfuric acid in some cases directly on site. It's recommended to do this on a daily or a weekly basis, depending on throughput. Some customers can also analyze some of the contaminants like trivalent chrome and iron. Usually, Atotech provides, as a part of our customer service, we're providing full analysis on a monthly or every several months. We will make a full analysis, including all components and, of course, catalysts and also special impurities or surface tension or whatever is required. Usually, we provide this full bath analysis free of charge to our customers, up to a percentage of 2 to 5% of cost in relation to the annual turnover. Also, recommendations for bath additions will be done afterwards. Yeah, dealing with the automotive industry, we also it's coming more and more for analysis tracking. So it's also possible to provide spreadsheets where the analytical data is put in, and then you have a graphical sheet which is showing you also warning and action levels when some of the parameters getting out of range. Here you see the influence of temperature on the plating bath, which will mainly, a drop of temperature will mainly cause roughness and nodulation. You can see this in the top pictures. When the temperature is dropping, the surface is getting very, very rough, and you get these little bubbles, which you can also feel with your nails on the part. So always the temperature and the current density have to match. This means actually there is a certain area where the chrome is plating bright. This is the yellow field in the middle. And when you want to plate faster and you increase the current density, the chrome would usually burn or get these roughness. So in order to avoid this roughness, by increase of temperature, you would move back into the bright area, and this roughness will be reduced or removed. With the heave type processes or dinachrome type processes, these increase of temperature and the resulting in a drop of hardness, it's not happening with the heave type of process. It will happen with a sargent type or conventional baths. Increase of temperature there will result in a drop of hardness, but the catalyst system in the heave process is avoiding that, so no hardness drop with increased temperatures with the heave system. Here you see the influence of the bath constituents on the performance of the layer or on the properties of the layer. Top left is chromic acid concentration. You see at chromic acid concentration of around 250 to 300 grams per liter, we have a maximum in current efficiency. And a drop of chromic acid or an increase of chromic acid, extensive increase of chromic acid will result in a drop of plating speed and also a drop of microcrack count. Sulfuric acid is needed in order to plate the chrome. As a first catalyst, an excess of sulfuric acid will result in a drop of plating speed and also a drop of throwing power and metal distribution on the parts. On the bottom table, you see the effect of the catalyst, the organic catalyst, which is used in the heave process. It's mainly there to increase the plating speed from 10 to 15% in sargent baths up to 25%. And also it provides the high hardness and the increase of the microcrack count. You see the green line, the hardness is not changing in any of these tables. This means hardness in heave process is very, very stable. As a rule of thumb, you can say if the chrome is coming out bright of the plating bath, the hardness is typically minimum 900 Vickers hard. Chrome only loses its hardness when it's heated up to more than 400 degrees, the layer, not the bath. If the layer is getting these high temperatures, the chrome will get softer. Coming to the equipment, let's see, I have to speed up a little bit. There's typical ways. Usually customers use conventional lines, which is actually a plating tank with some stirrers, some heaters, some cooling, the rectifiers are connected over copper bus bars, and the parts are entered vertically into the tank and plated. There is exhaust systems in order to remove the emissions or the spray which can be generated. There can be storage tanks, and these lines can occupy quite a lot of space. Another type of plating lines can be continuous plating lines for cylindrical 6-meter bars. Here you see a sketch of such a system. in this kind of operations, the parts are transferred horizontally from the loading module on the bottom right side. They are transported horizontally through the plating tanks in the middle of the system with the red circle, and they are unloaded on the unloading sections. Typically here, cylindrical bars are plated with diameter range up to 100 millimeter, partly even 200 or 300 millimeters are possible. These kind of systems can plate up to 1,300 meters per day of hydraulic bars. Then this happens only with a volume of 1,000 to 2,000 liters in each module. So the amount of chemistry is significantly reduced in these kind of machines. And then as an example, there's high-speed plating equipment in this case, for automotive shock absorbers. It's our Dynachrome system. With a footprint, you see on the picture, it's a completely housed system. So all the chrome and all the emissions are staying inside the enclosure. So workers don't get in contact with the chemistry anymore. And with a footprint of only 72 square meters, these kind of lines are able to produce 350 to 1,200 rods per hour. So plating of 5 to 6 million shock absorber pieces per year is possible, with the plating length of about 500 millimeters and diameters from 11 to 25 millimeters. We're plating here really to the required thickness without any overplate. These lines are operated worldwide. Actually, Atotech is actually on the world. There are more than 50 of these lines are actually in service. Dosing is also very important. So with the new types of lines, the dosing system is getting more and more automatically. So manual additions of chromic acid and catalyst are not required. The dosing pumps are dosing the liquid chromic acid and the liquid additives inside the plating tanks, depending on ampere hours. So bath control is very, very stable. As a part of the safety features, we also offer automatic sample taking stations, which are connected to the chrome tank. So not necessarily anymore to enter the plating line and to remove the sample. Just by pushing a button, a sample can be extracted here. This can also be transferred to conventional plating lines. As part of the wastewater system, we operate our Dynachrome lines with ion exchangers in order to remove iron and trivalent chrome from the plating bath. This is possible in different resin sizes depending on how much contaminants are built up. The columns can be from 25 up to 500 liters of resin. And as part of the high requirements for the automotive industry, this kind of systems are required in order to keep the contaminant levels very, very low to have a good quality of the chrome plating. Some words to the anodes. Typically, lead tin anodes are used with 4 to 7% of tin. Lead antimony is also of choice when the anodes get very long, because it's more stable. It's providing some more stable shape. And also silver was added in the past in order to avoid chloride contamination or to fight chloride contaminations. Nowadays, sorry, I was one step too far. The lead dioxide, on the lead anodes, there is typically a lead dioxide layer formed during the plating. You see this on the left side. On this layer, typically the reoxidation of trivalent to hexavalent chrome is happening. In idle times, this layer is destroyed by the chrome bath, and if the anodes are very long in the solution without current, lead chromate can form, which will also reduce the shape or the diameter of the anodes. For that reason, nowadays, the industry tends also to move over to platinized titanium anodes. It's a platinum mesh with a thin platinum mesh with a thin titanium mesh with a thin platinum layer the shape will be constant over the complete lifetime. So there's no changes, no bending, no anything on these kind of anodes until the platinum layer is worn up. The problem with these kind of anodes is the reoxidation of trivalent to hexavalent chrome is not very efficient on the platinum layer. For that reason, Atotech has developed several processes for the use with platinized titanium anodes. We call it we call it TCC, trivalent chrome control. These kind of processes have a certain special additive which improves the reoxidation of trivalent to hexavalent chrome on the platinized titanium anodes, like HEAF 25T, HEAF FCT, HEAF HMC, and also the Dynachrome Plus and Dynachrome Ultra processes. They have these certain additive to improve the reoxidation. Yeah, these the platinized titanium anodes are also wearing. So the platinum layer is reduced during operation, which basically means the lifetime is the lifetime has an end. Typically, lead-tin anodes are changed every 1 to 2 years. Platinized titanium anodes last definitely longer. Usually the lifetime is depending on the current applied and on the throughput. It's between 3 and 7 years, also depending on the platinum thickness of the anodes. Yes, so much from my side. For the last slide of the summary, I will now hand back over to Shakil.
Thank you, Matthias. To summarize our presentation here, we can say that hard chromium deposits offer a unique set of properties which assist to improve the service life of the components, such as resistance to wear, which is achieved through the high hardness of the chromium layer, low coefficient of friction, and high crack count in the deposit, which can retain oil for lubrication. Superior corrosion resistance, which is achieved by the preparation steps of the substrate surface prior to plating, and the optimum crack count number produced by the best operating parameters of the plating process, as well as the post-finishing steps applied. The coating is highly stressed as plated due to changes in the chromium hydride structure, giving rise to deposit shrinkage. The stress is relieved by formation of cracks in the deposit. Pre-treatment and post-treatment steps are very critical to achieving the highest level of corrosion protection and can contribute to crack formation. Atotech offers a full range of plating processes to meet all aspects of hard chrome plating requirements, and it provides extensive service and support to its customers. And on that note, I say thank you to all for attending this seminar, and I now hand back to Katrina for the question and answer session. Thank you.
Thank you, Shakil and Matthias. And again, I would like to apologize to our attendees. We were facing some technical issues, but we are all good now. So I want to welcome everybody once again, and thank you for joining us. We will now proceed with our Q&A session, and I would like to remind you that we will cover as many questions as possible now during the Q&A session, and all the rest will be answered by Shakil and Matthias after the webinar via email. So I would say let's start. The first question, what is the difference between HEAF 25, HEAF KR, and HEAF HMC?
Shakil, you want to answer that, or should I do that?
I think you can answer this, Matthias.
Yeah, I already made a comment during the presentation. The difference is actually the catalyst system, and the processes from HEAF 25 over KR to HMC represent the increase of the demand of higher corrosion resistance over the last years. So basically, a higher corrosion resistance and higher micro crack count was required. Therefore, the original HEAF 25 process was improved with different catalyst systems in order to provide higher number of microcracks. So the HEAF 25 will provide the lowest at KR middle, and the HMC will provide the highest number of microcracks.
Thank you very much. And there's another question. Is there any effective way to clean platinized titanium anodes?
There is typically on the platinized titanium anodes, you can have some layer formations. Basically, when they're without current in the chrome bath, the cleaning is very, very well. But of course, they can also be removed to rinses and can be treated with some mild acids. In any case, it's not recommended to use any kind of abrasive cleaning like with brushes or anything like that, because this will definitely destroy the platinum layer and will destroy the anodes.
Thank you very much. What type of parts can be plated in Dynachrome?
Yeah, the Dynachrome system is mainly tailored to automotive shock absorbers. So cylindrical parts, yeah, it's actually shock absorbers. There's one application which might also be possible. This is suspension struts or front forks for motorcycles. This is the two types of parts which can be plated in Dynachrome lines.
Thank you very much. Let me see. We have another one here. What is the minimum thickness required to achieve sufficient corrosion protection?
I'll try and answer this. In terms of corrosion protection, there are various factors which influence these particular properties. The most important factors are that we need to make sure that the substrate we are plating the chrome layer on top of is completely defect-free. So any defects on the substrate will have negative effects on corrosion resistance. So most applications for hard chrome deposits in terms of corrosion protection will depend on the environment that the parts are subjected to, and also the pre-grinding and post-finishing operations after plating. So in most cases, for example, if we take brake pistons, for example, typically we plate 8 to 12 microns on these. And because these parts are usually covered with the brake fluid all the time and not subjected to the outside environment so much, then 8 to 10 microns is sufficient. Whereas if we're looking at oil and gas industry applications, where we have very high abrasive conditions and also very corrosive media that the deposit has to deal with, then you need deposits in excess of 100 microns. So the thickness is very dependent on the application and the substrate quality, basically.
Thank you very much. Can you give us some guidelines on grinding and polishing conditions?
Actually, this is it's a good question, but the answer is quite simple. Atotech we are specialists in plating, and the grinding, pre and post grinding, is really not the field where we are the real experts. Of course, we can give some recommendations or guidelines what kind of surface finishing or surface quality is required for the certain requirements of the part. But if it's going into detail of grinding, it's better to ask the grinding line or grinding stone suppliers, with, of course, also with our support, asking them what you want, what is your substrate, and what final result you need. And then they can give you a really detailed and good recommendation on what grinding stone, what grit, how many grinding steps, etc., are required to reach this goal. In any case, we can assist there or support these conversations with related to grinding.
Thank you very much. I'm really sorry we are running out of time. So if your question has not been answered yet, don't worry. We will send all the questions afterwards to Shakil and Matthias, and they will get back to you by email. So we come now to our last question. Can your Dynachrome ion exchange system be used on conventional processes?
Yeah, also a very good question. Usually, from the technology point of view, it can also be transferred to the conventional plating systems. The threat is, in order to run ion exchange, the solution has to be diluted in order to not destroy the resins by the very highly oxidizing chromic acid. So it has to be diluted 3 times with water. For the Dynachrome system, where we have a very, very high evaporation in the plating tanks, it's no problem to get all this liquid back into the plating tank. In conventional systems, you typically run lower temperatures and you don't have so much evaporation. So the ion exchange system is not very cost effective on conventional plating systems. What some customers are doing, they're running an ion exchange system on the first rinse after chrome, in order to remove the dragged out contaminants from the first rinse from the complete system. So it's possible, but the cost effectiveness has to be reviewed before very, very critically.
Thank you very much, and stay healthy and safe. And I hope to see you next time. Thank you so much, and bye-bye.